In this section, we'll learn how to evaluate a logarithm or find its value. So you have log base 5 of 1/125th, and that's just an expression, not an equation. If we want to find out what it's equal to, let's let it equal a variable x and then solve the equation. Next step is we're going to put it in exponential form. So we have to ask ourselves, what is the base? It should be 5. What's the exponent? And you remember that a logarithm equals an exponent, so x must be the exponent. And that's equal to 1/125th. Next, we're going to express the right side of the equation as a power of 5. So 5, we know 5 raised to the negative 3 is 1/125th power, 1/125th. So that must mean that x is equal to 3, or rather, I'm sorry, negative 3. So negative 3 is the value of the logarithm. Same thing for b. We have log of 100. So we're going to think we're setting that equal to x, or equal to a question mark if you prefer. And then we ask ourselves, what is the base? 10. What is the exponent? That's the part I don't know since it's on the opposite side of the equal sign from the log. And that equals 100. And 10 to the x is equal to, and 100 is 10 squared, so that must mean that x equals 2, so log of 100 must equal 2. And in C we have the natural log of 1, and we're going to think of that equaling x, asking ourselves what is the base, e, since it's a natural log, and what is the exponent, that's what we don't know, equals 1. Well, if I have a result of 1, we know that that's from raising something to the 0 power. So x must be equal to 0, and the natural log of 1 is equal to 0. In D, log base 4 of 32, we're going to solve the equation 4 raised to the I don't know, since we don't know what goes on the opposite side of the equal sign from the logarithm, that's the exponent, equals 32. Now this one's just a little bit more complicated to solve. 32 is not a power of 4. So what we can do though is we can write these both in common bases. 2 squared is the same as 4, and 32 is 2 raised to the 5th power. When you raise a power to a power, you multiply the exponents. So 2 to the 2x is equal to 5. That's going to give us equating the exponents. 2x is equal to 5, and x equals 5/2. So that means that the log base 4 of 32 must equal 5/2. Let's keep going. The log base 9 of 1/27th. So our base is 9, our exponent is unknown, and that's equal to 1/27th. Again, 27 is not a power of 9. But both 9 and 27 are powers of 3. So 3 squared raised to the x power equals, and 1/27th is 3 raised to the negative 3. So that gives us 3 to the 2x equals 3 raised to the negative 3. So that means 2x is negative 3, dividing both sides by 2, negative 3/2. And lastly, the natural log of e to the 7th. The parentheses are there for clarity so that we can see that e to the 7th is what we're taking the natural log of, rather than taking the natural log of e and then raising that result to the 7th power. All right, so our base is e, because a natural log always has a base of e. Our exponent is unknown, and the result is e to the 7th. So we don't have to do anything with that one. We just equate the exponents, and so the natural log of e to the 7th is 7. All right, your turn to try A. Pause the video and try this one on your own. For A, you should have found that the log base 6 of 136 equals negative 2. All right, try B now. For B, you should have found that log of 1,000 equals 3. Now try C. This result should have been 1. To what power do you have to raise e in order to get e? To the 1st power. All right, now try D. This last one should have been the fraction 4/3. And that's it for this section. Now you can do the practice for B2.